Hello everyone and welcome to the Synetiq tutorial about what the company does and how to measure emotions and what is neuromarketing. I'm Tamas and I have a background in psychology and I'm especially interested in stress and emotion research and psychophysiology. I have been working at Synetiq, which is, as you know, a neuromarketing company that uses biometric sensors to measure emotional reactions in the audience. In this talk, I'm going to discuss emotion research and what are emotions. I'm also going to talk about the current state of neuromarketing and the best practices in the field. We are going to talk about what Synetiq does, what sensors we use, how we process the data, and we are going to discuss how we compare to the competition and what other companies do. In this first part, I'm going to talk about what are emotions, how can we classify them, what is the role of emotions anyway, what tools are available to measure emotions, how is the scientific investigation of emotions is done, and how can we elicit emotions in a research context. Everybody knows what emotions are, but no one can really define it. Even scientists cannot completely agree on what they call emotions. What scientists can agree on is that emotions have several smaller parts that constitute the whole emotional experience. What we usually call as an emotion is the subjective feeling, for example, the feeling of anger or sadness. But apart from that, four other parts constitute emotions. A part of the emotional experience is the cognitive appraisal, which is our mindful evaluation of a situation. This, for example, defines the importance of an event. And if we believe that an event is important for us, then it will have a bigger emotional impact on us. In contrast, an unimportant event will leave us completely unaffected. Motivational tendencies are also parts of an emotion, and these define how we are going to behave in this emotional situation. For example, whether we want to approach a desirable object or we want to avoid something that's, for example, disgusting. The expression of emotion is also an integral part of the whole emotion, and this does not only mean the facial expression, however it's obviously an important part, but it also refers to other movements and other ways of expression, for example, speech. Physiological reactions are also integral parts of emotions. There are different body reactions to sadness than to anger or happiness, and different psychophysiological measurements can make a distinction between these emotional states. So if we want to really define emotions, we can say that emotions are brief and consistent sets of reactions to internal or external events which have a particular significance for the person. We can also make a distinction between emotions, feelings, mood, and affect. Feelings are basically the subjective feelings, which are only a small part of an emotion. Mood is a less intense, diffuse, affective state and there is affect, which is an aggregated term for mood, emotion, and feeling. There are two main ways to classify emotions. The first is when we classify emotions as discrete states. Think about the 6 basic emotions: anger, disgust, fear, happiness, sadness, and surprise. These are discrete emotions, and we can talk about those in everyday situation, and everybody knows what we are talking about. And these are deeply embedded in our culture and language, and they are also culturally independent. So people in Japan has the same facial expressions for surprise, for example, than someone in Europe. However, distinct emotional states are a bit difficult to handle in research context, because obviously we have many more than just 6 basic emotions. The 6 basic emotions are only considered basic because those are hard-coded and are independent of culture based on facial expression. Therefore, in everyday situations or even in research situations, our reactions are more mixed than just those limited set of emotions. It would also be a bit difficult to accurately describe differences between stimuli based on discrete emotions. The other approach to classify emotions is when we see it as a dimensional construct. For example, we can talk about the pleasantness and the emotional intensity or arousal that a situation elicits. Even though this approach is less natural for everyday use, it is more easy to use in research context, and it's much easier to compare situations or stimuli based on this approach, because we can say that situation or stimuli A is more pleasant than situation B. So why we even have emotions? We know that non-human animals, much less evolved than humans, have very similar emotions than humans. So this suggests that emotions have some evolutionary aim, or somehow increase our chances to survive and to proliferate. The evolutionary benefit of having negative emotions is quite obvious. Usually when we have a negative emotion, for example fear or disgust, that tells us to do something differently, and for example to flee from the place where we are at. So these aversive states facilitate immediate changes, and it narrows down our behavior repertoire. When we face an angry bear, our emotional and behavior repertoire narrows down to fear and to get away from the situation as fast as possible. That boosts our survival success. The evolutionary benefit of positive emotions is a bit less obvious. Positive emotions such as joy, emotional engagement, and deep interest keep us in the activity that we are doing. This way we can learn more from a situation compared to one that we don't enjoy, and also we can get better at what we are currently doing if we enjoy it. This is the broadening of our behavioral repertoire by learning new things and getting better at them, which will boost our long-term survival. From a heuristic perspective, emotions are hard-coded reactions that help us to make decisions. The Nobel laureate Daniel Kahneman coined the dual process theory, which offers a theory about the two main ways we make decisions. System 1 is basically intuition. It's an unconscious, fast emotional reaction that requires very little mental effort, and it is mostly automatic. System 2, or the reasoning system, is what we traditionally call a decision-making process. So it uses argument and logic. It's a conscious, controlled process and requires a lot of mental effort. This approach implies that at least some, but most likely most, of our decisions are based on intuition rather than reasoning. There are several ways to measure emotions. The most obvious is to ask it from the people who experience the emotion. So we can conduct interviews, we can use self-report questionnaires and scales. We can also observe the behavior. We can measure if someone is more aggressive. We can collect tweets about an event. We can analyze voice pitch to infer stress. We can analyze movement patterns. We can also measure reaction time in timed experimental tasks, and we can infer emotional states from these actions. Another way to measure emotions is to record involuntary movements such as facial expressions, but we can also measure blushing or blinking, and movement and posture, nonverbal communication, eye movements, and so on. These are still observable by the naked eye, but those are pretty small movements. Let me tell you an example about what we can infer from involuntary movements, or the lack thereof. There was this movie in 2016 with Leonardo DiCaprio, which was called The Revenant. It was a really exciting movie, and a company decided to use biometric wearable sensors to make a neuromarketing study about it. They used the usual neuromarketing methods such as heart rate and skin conductance, but those are not that interesting. What is interesting for me is that they also used movement detection, or gyroscope, and they looked for moments when the audience was completely still, and that behavior happens when someone is really involved in what's happening on the screen. We already discussed that emotions have something to do with our psychophysiologic responses, or the way our body responds to emotions. And we can, on that term, infer emotions from measuring heart rate, blood pressure, skin conductance, heart rate variability, and so on. We can also measure biomarkers from blood, saliva, urine, hair, and so we can infer emotional states on a bit longer term by measuring the saliva volume, testosterone or cortisol levels, and so on. The most direct way to measure emotions is when we measure the activity of the brain or the central nervous system. This can be done by using functional magnetic resonance, or EEG, or near-infrared spectroscopy, or other methods. There are a number of problems when we want to infer emotions from psychophysiological states. One problem is that there is an individual variability of psychophysiology. So different people show different baselines, and also different people show different reactivity to the same stimuli. Another problem is the problem of specificity, where two stimuli that is supposed to elicit the same emotion is going to elicit a different psychophysiological reaction pattern. The problem of contextuality means that the emotions heavily depend on the context. For example, running when you feel fear is different when you run for fun. But if you only observe the running movement, then you cannot really know what the person felt. Because of these reasons, it is best to create an experimental context when most of the things that we can account for are controlled, and this removes the contextual bias as much as we can. There are 4 ways we can elicit emotions in research context. Perception is the most obvious when we are showing pictures or videos, or the participants have to listen to sounds, or when they have to reach into a can of worms, literally. We can also ask participants to think about a situation or event that they experienced when they felt a particular emotion. For example, think about when they felt really surprised or when they felt a deep grief, and describe what they felt. Usually people start to experience the whole emotional package if the instruction is right. So they really start to feel the emotion, and they start to show all the psychophysiological reactions associated with it. Anticipation also elicits emotion. For example, when we are waiting for the end of a horse race and we are looking forward to win, or when we are waiting for an operation in a hospital for a beloved one. Summarizing this first part, we learned that an emotion has 5 components, and emotions serve short and long-term survival. Emotions bias our choices and serve as an aid in decision making, and we can measure emotions and infer emotions using several methods. However, the context is very important to know, and there are several ways to elicit emotions experimentally, but not all emotions can be elicited with the same method.